I've been working in precision ag since we started getting GPS. The group of extension advisors, were looking at the technology as it was coming back in the 90s, and we just happened to make contact with somebody from Trimble, and they were in the surveying industry, and they knew that agriculture was going to be wanting their GPS systems, and they were willing to loan us 4 backpack-sized GPS units that were huge, and the antenna stuck up on a pole over your shoulder. The guy that came and trained us on them said that when you're out in the field using this, if anybody asks you what you're doing, just tell them you're a ghostbuster. Because if you tell them that you're receiving signals from space that tell you where you are, they're going to look at you very strange. So precision ag has been something I've been working on for quite a while. I thought GPS was fun. UAVs are even a lot more fun than that. I really first got started with UAVs a year ago last winter. What I'm going to be talking about is not pulling a predator or backing a predator into your farm shop. But farmers are known to be tinkerers, and they like to work with things. And what I'm here to tell you is that you can work on these devices and make some modifications to them and learn more about the technology as you're doing it. So what got me started was an AR drone. I call this my gateway drone. It got me started, and it's been downhill ever since, I guess. How many of you have played with an AR drone? They're so easy to use. They've got a high-definition video camera on the front that takes really good images. Easy to fly and cheap. You run them off of your iPad or your smartphone. You just touch the screen and tilt it whichever way you want it to go. There's a takeoff and landing button. You don't even do that on your own. It just jumps up in the air, and you can start flying the thing. I knew when I ordered it that it had 2 cameras. It had a camera, forward-facing camera, and it had a downward-facing camera. And I thought, oh, this will be good. I can fly it up over crops. I can take images down of the crop. I bought it and found out that the downward-facing camera is useless. Its whole goal in the system is important, but its whole goal is basically just to try to hold an image steady looking at the ground so that it uses that instead of a GPS signal. So it uses that downward-facing camera to track its spot over the ground, and that's how it tries to hold position. It's not useful for imagery at all. So some of the bad points were it didn't have GPS, the camera on the bottom was really poor, and you were limited in range to the Wi-Fi range of your tablet or your smartphone, which can make you really tall. That's what I told folks when I was talking about this device. It could make me really tall. I could go up to the edge of a field, launch this up in the air, look out over a field, and get a good perspective of what was going on out in the field. I couldn't send it very far out, but I could do that, and it was still quite useful. I used it last summer and got a lot of video and pictures of some of my plots. So I was thinking that we could improve this and do some modifications. So I was hoping I could get a camera to take the downward picture. So I bought a GoPro, hoping I could strap it to the bottom and take pictures with it. That did not work. I could not get it to mount to work, and when I did get it on there, its flying characteristics just got really bad and hard to handle. Over the time period after I bought it, the parent company did come out with a GPS add-on. One of the things, it has a USB port built into the drone, and you could add a little USB stick that had a built-in GPS device that the company made, and you could add GPS to it. That kind of worked. I had trouble getting it to really lock on and do what I was hoping it would be able to do. And plus, when you added that GPS unit, you could no longer put that hull on the device. You couldn't put the shell over the top because it didn't fit anymore. So then you had to just kind of fly the naked drone around the fields. I still use it for demonstrations and meeting rooms. With the indoor hull with the kind of clover leaf that protects all the propellers, you can fly it around inside pretty well. But when you're flying it in a conference room, if there's a lot of handouts on the table, you don't want to fly over the audience because it sends things all over with the amount of air it's moving. The one thing that I did do to it to modify it that really did help was that high definition camera that sticks out on this styrofoam nose on the front of the AR drone. I found a YouTube video online that said, here's what you do. You cut a little pie-shaped wedge of that styrofoam out and you can angle that camera down. So instead of taking 50% horizon and ground, you can tilt that down a little bit so you get more ground in your image, which is what I was wanting. So that helped, and that was a good success on the AR drone. And like I said, this was the gateway drone. It kind of broke the ice and got me started, and I started thinking about this and what could I do, what other options were there that would be a little more, provide a little more information to my research plots. So I got a Phantom. The price, I'd originally looked at the Phantom when I bought the AR drone, and the Phantom prices were up around $900. By last fall, the prices were down to less than $500. I thought, I can buy this with my university purchasing card and not raise any eyebrows to anybody else because I'm under the $500 limit. You know, don't have to ask anybody's permission to go do this. So I bought a Phantom drone. This was the version 1.2. Came with the little mount for the GoPro. The GoPro I bought for the AR drone that never worked. I could put it on here really quick and it was ready to go. You know, some of the good things about the Phantom 1.2, cost, cheap, relatively cheap. It has the built-in GPS. That was a great feature because it locks and holds its position really well, and when you get it out to any range at all, it's a small device, and even though it has these bright lights on it and the red stripes to tell you which direction it's headed, a lot of times you lose orientation when you get it out real far away, over a quarter mile away or so, and it's sometimes hard to remember which way to pull the stick to get it to come back. But with the GPS, you can put it into fail-safe, and the GPS will fly it, return home automatically, which is a great feature. Some of the things I didn't like about it was it didn't come with the camera, but I already had one, and it came with a mount, so I could put that on there and start flying. Still, you know, the GoPro doesn't weigh very much, but it's still kind of a limited payload on the Phantom. So modifications, mounted the GoPro on there. Wasn't totally happy with that because I was getting some vibration in the images, and it was kind of a fixed position. I could aim the angle of the camera at launch, and then it was kind of stuck in that for the entire flight. So they were also trying to sell gimbals, these little stabilized devices that keep the camera aimed in the same direction and keep it level despite the attitude of the drone. And you've seen that in some of the pictures today from these drones, and when the horizon's kind of tilted at an angle, that's because these copters, to keep their position in a wind, they lean into the wind, and that can shift off the angle of the camera as well. So we put these stabilized gimbals on there that keeps the camera level. And I also added the carbon fiber propellers that give a little more lift and a little less vibration. The gimbals also came with these rubber mounts that kind of isolate the camera from the drone itself, and that made the video and the images a lot clearer. It lost what they call the jello effect from the video. And it came with I could also get this very cool travel case that packed it all in to make it easy to carry and move around, and made you feel just a little bit like James Bond or something, because it's just all right there. You open it up, pop this thing out, put it up in the air, and it's just cool. One of the problems I did run into was the fact that when I bought the gimbal, I called the company because there's some Phantom, when they were, or DJI, when they were making these, whenever they came up with an idea to make it better, they just put it into the production line, and they would add, they'd go from version 1 to 1.1 or 1.2, and what was inside was not always set for sure. So I knew I had a 1.1. I wanted to add the gimbal that DJI was selling, specifically for the GoPro camera. And I called the vendor and said, this is I have a V1.2, this is the drone, or the gimbal I'm going to order. Will it work? Do I need any other parts to make it work? He said, nope, that's all you need. I got it, it did not work. I discovered that they had changed, there was a new circuit board right there in the heart of the Phantom that everything is mounted onto. That has a special connector for the gimbal. And so for another $60, I could have the new circuit board that would control the gimbal. Okay, all right, I'll buy one of those. So I bought one, saw the video on how to open up the drone, take the propellers off, take out 4 screws per arm, so about 12 screws, or 16 screws, there we go. And there you have the guts of the Phantom. Now I was stuck because everything is soldered onto the control board. And on the farm, when I was raised, I learned how to solder copper pipes. And soldering electronics and circuit boards is a little bit different. So I went online, watched a couple videos on how to solder electronics, went to Radio Shack, got a soldering iron and flux and the right kind of electrical solder, and went and desoldered, got all those wires loose off of the control board. Each motor has 2 leads that fasten on to the control board, and the main power leads that go to the battery, those all fasten on to the control board. So there were 10 leads that needed to be desoldered and then resoldered back on, and then it was just plugging everything back together and screwing it all up and putting the covers on, and it worked. So I learned how to solder and lost some of my fear of making some modifications to electronics. Wasn't all that difficult, but there was a major hurdle there to get it done. One of those things that I wish somebody had told me and had been able to find it easily online was that as I was wanting to buy more batteries, because as I was flying, I wanted to have charged batteries, spares set up and ready to go, and you can often find cheaper batteries from different vendors online. With these amazing lithium polymer batteries that crank out so much energy and make kind of a lot of this all possible, they are different than A's and AA's and D's and C batteries. There's a lot of numbers that go with these batteries. They relate to how many cells are in the battery. And what you see in one of these chunky batteries is actually a series of foil pouches that are all filled with this gel that makes and stores the energy and releases it back out. And so how many cells are in that series, and that relates to how many volts that the device has, because you need to know that, because some electronics need specific voltages and they don't want to operate outside that range. So if you put too big a battery on a system that only can go up to a 3S and try to put a 6S battery on there or something, you can have problems because the voltage is wrong. How much power do they store? How many milliamps of energy do they put on and can they put out? And how fast will they release that? So here's an example of one of those batteries. This is a 2200 milliamp 3S battery. So there's 3 pouches in this package, and it puts out 11.1 volts. And the 30C is how fast it can release that energy. So that's what percentage of an hour, or not percentage, a fraction of an hour, that will release all that energy. So a 30C, so 30 divided into 60 is 2 minutes. So at maximum discharge, you can empty out this battery in 2 minutes. Don't short it out because it will blow up. But how fast can it release its energy, which relates to how nimble your device is going to be. How quickly can you put new fresh energy into those motors to get it to respond. But these little foil pouches and all the energy that's in them has some safety characteristics that are different than other batteries because they can overheat. There have been fires and houses that burned down because these batteries were not handled correctly. You're never supposed to leave them on the charger when unattended. You need to be careful of where you store them. And if they ever look like they're puffing up, then you need to dispose of them and get rid of them safely and get them out of your range. I had my first one blow up yesterday. It accidentally got a short in one of my leads and went bam. And it was, the grad student that was with me was surprised, as was I too. So the other thing is when you order the batteries, they have different connectors. And the hobbyists know what all these different connectors are, but us in agriculture are in new territory here. And so as we need to have a little bit of familiarity with what our devices have so that when we order parts and batteries that we make sure that they have the right attachment so we can actually use them. Let's see, oops, wrong button. Okay. All right, can't see that. The yellow connector there is what the Phantom has. My newer device I'm going to talk about in a minute has the EC3 blue connector. There's an EC5 that looks just like that, but it's bigger, and they're not interchangeable. I also have one of my parts that I ordered came with the DIN connector on it, so I had to have an adapter so I could convert the DIN connection to one that we already had on my system. The AR drone has the Tamiya connector on its battery, so that was useful. Some of my small devices have the JST connector on it, so I've got one of my battery charger leads has power leads on it, and then it has all these different, almost all these on it all grouped together, so I can have this one wire that I can charge just about any kind of battery that I come across on. But that was interesting trying to figure that out, and going online was still even trying to find a place that had them all in one spot was somewhat of a challenge. The Phantom was doing really good work for me last fall. I really liked it, and I wanted to go this next step beyond visual imagery to NDVI. I found this modified Canon PowerShot SX260 that will do NDVI imagery. Comes from MaxMax. There's a graph of what the wavelengths it collects are, the blue, green, and near infrared. Buying the camera from them with the modification and the software is right at $900 for that camera. But it was too big for the Phantom. So now I had another problem. Or an opportunity, you could say, I guess. So I started this project early this spring to make a device that would horse up that NDVI camera. Even though it's not very big, it still was a little much for the Phantom. So I looked online trying to find some economical parts to put a system together. Online you see a lot of the DJI stuff. They make a hexcopter called the F550 flame wheel, and one of the places I saw online had the flame wheel, what they call an almost ready to fly kit, ARF, came with the motors, the speed controllers, and the skeleton and propellers for 318. So I started putting that together. Again, I had to solder the speed controllers onto the main circuit, the base circuit board that you see there in the middle of the picture, and start bolting it together. And after I got the motors soldered on and the main power lead soldered on, I had to add my autopilot, and the autopilot I picked was a budget range autopilot. It's also from DJI. It's a NASA V2 with a GPS, so that cost me around $299 for that. Has the ability to do waypoints, but you need extra stuff to do that. Has the built-in GPS. Also has some built-in gimbal controls built into that autopilot. Has the return to home feature. So this is kind of the low end of, they make a light version that's a little cheaper, but this is kind of the low end for autopilots that are available for these hexacopters. Another reason I wanted to go with the hexacopter was with 6 motors, and another feature of this flight controller is that if you lose one motor, it will still land safely. They won't say it'll fly well, but they say it'll land safely. So that was one of my selling points with this device. So added the autopilot onto the system. The autopilot has the main box there. It also has a little LED panel that fixes onto the back of the drone. That's how it communicates and lets me know that it's got a GPS signal, and if everything's green and ready to fly. And I've learned you don't ignore that. The other thing with these autopilots is I've learned that if they are not happy in giving you all green or whatever the right signal is, you need to pay attention to them and not fly. Because really, you do not fly these hexacopters. They fly themselves, and you suggest where you think you want them to go. And you can make bad decisions, and it will not overrule you for making bad decisions, but it will take care of most of the details of keeping the thing level and in position. Then you need the radio and the transmitter. Those need to be matched because they need to work together, so you need to make sure you get those from the same company. You need to know how many channels you need to control your device. I've got an 8-channel device with an 8-channel receiver. It allows me enough room to control the parts of the drone that I need to control. And once you put them all together, you also need to bind the two when you turn them on. The different companies have different ways that happens, but you need to make sure that they're synced with each other. As you're picking a radio, you also need to know what your autopilot needs in the way of inputs. The NASA has two different modes or selections where you need a 3-position switch to tell it how you want it to behave. And so you need, the first receiver I bought actually did not have any 3-position switches on it, so I had to send it back and get a different receiver. And so make sure it has the right kind of controls to do your device. One of the most challenging things was programming that receiver to match my autopilot. I found a great YouTube video. I still don't understand how to do it, but it walked me through every step and setting every switch and each of the modes on there, and it works. So that was important. The next thing I decided at each step here, I got the thing running and flew. From this point on, I flew and made sure it was working well, and then I'd do that for a while and decide, okay, the next thing I want to add is, and so one of the things I added was the first-person video, so that I could see what the camera was seeing. So as I'm trying to set up and take pictures of our research plots, I want to be able to frame those well, make sure I'm getting what I want, and the first-person video really does that. The other thing it does is when you get the drone too far away from you, you can still use that camera to orient yourself on the horizon or where you are and aim it back so you can bring it back in a little more easy. It's another kind of fail-safe. It also has the on-screen display so that it inserts in that video signal the altitude, the position of the drone, and those kind of information as well, speed. All right, so the parts of that, the camera, the on-screen display, the video transmitter, the receiver, and a monitor. Then I needed a way to mount the camera on there. And so I actually looked online to find somebody else that was flying a 550 flame wheel with the Canon camera. And I found a crop consultant in Canada that had a rig that was doing that. I sent him an email. He was very nice. He responded back and said that he was using a Havafilm Phoenix landing gear camera mount system on his drone. I ordered that and found out it was coming from Turkey. It was available in black and red. I ordered the black. They sent me an email saying we're all out of black, but we have red. If you want to wait 2 weeks, we'll send you a black one. I said, no, go ahead, I'll go for red. So I have a red landing gear on my system. The camera mount, you need those. We talked about the stability of that. The other thing is the ability to change the pitch of the camera from being horizontal to being vertical. In flight can be quite a nice thing to have. So I've got that on there as well. So altogether with that, the total price came out to being about $1,660 for that system. And that's what I've been flying this spring over our plots and collecting the NDVI imagery. And I can swap out that and put the GoPro on there if I just want visual as well. Still doing the Phantom as well. So, all right, out of time. Thank you, Orb.
And thank you very much. I say thank you.